Hello, thank you for joining me today for part 1 of our AI to 3D series, as we take a look at creating Unreal Engine 5 materials that have the illusion of depth, using Parallax Occlusion Mapping together with seamless textures generated using AI within Comfy UI. In Unreal Engine 5, Parallax Occlusion Mapping, POM, remains highly relevant for adding high fidelity per pixel depth to surfaces. POM uses iterative ray casting, which can be expensive. It is best used on close-up objects or to enhance, rather than replace, detailed meshes. Nanite can render massive geometric detail, but using POM on top of or instead of nanite displacement for finer details can still be more efficient for rendering. In summary, POM is a specialized tool for adding micro-detail efficiently in high-fidelity scenes, complementing rather than being replaced by nanite. So let's see what cool and creative things we can do with it that might be different than other use cases you've seen before. So let's get started. We'll begin by creating a new material. Let's name it MPOM Depth Master and double-click to open the material editor. So let's drop down a texture object parameter, followed by a named reroute node that we can name Base. This will be where we'll put the texture we'll make in Comfy UI shortly. For now, let's get the foundation of our material in order. Next, we'll need to take care of any UVs we have. I want to have the option of using both local 0 to 1 texture coordinate space or world space coordinates. To do that, I'll drop down an absolute world position node, a scalar parameter node, and feed them both into a divide node. Let's rename the scalar parameter to something like UV's world scale. That's the setup for world scale. Now let's set up local scale. Now drop down a texture coordinate node and another scalar parameter. You can just hit S plus left mouse click to place one automatically. Feed these both into a multiply node this time and name the scalar parameter something like UV local scale. Next, we need to drop down a switch parameter node and rename it to something like world space UV coordinates ? Feed the divide node from our world position setup into the true socket and the multiply node of the local space setup into the false socket. This last thing to do is pipe the output into a named reroute node and name it UVs. Now I always select the group of nodes after and press C to put everything in a comment box and name it accordingly. Then it's like its own little isolated thing. If you find this as a setup you would use often, then making it a material function would be even better. Here I'm only making the one material, so I'm not going to worry about making these smaller sections of logic into reusable assets. And for now it keeps everything a little easier to understand and on the surface level of this material. Next, we'll get a Parallax Occlusion Mapping node, which will help to create the depth effect we saw at the beginning. This is where all the heavy lifting for this material is done. Now we can pipe in our base reroute node to the height map texture. Height ratio, min steps, max steps, reference plane and shadow steps will each need their own scalar parameter nodes named accordingly. It'll take just a moment to pipe these all in now. Okay, now that we have those made, we can drop our UV's reroute node and pipe that into the UV's socket. Now we have to switch on some features of the Parallax Occlusion node by using a static bool node piped into render shadows. Go ahead and make sure we check the value to ensure it's active. Next, we'll need a way to handle normals, and I've decided I want to have the option to use a normal map derived from the base texture, or by using a custom normal texture. So let's set that up. So let's create the normals we'll need for if we use the base texture to derive a normal map. Let's drop a normal from height map node. We can wire in our base reroute node to the height map socket. Then we'll need another scalar parameter. So just press the S key and left mouse click to place one in the material graph. Next, we can place our UV's reroute node and plug that into the coordinate socket. Okay, now we can make the setup for custom normal map, which I'm also going to derive from a seamless texture that we will generate in Comfy UI. Now let's copy/paste the normal from height map node and move it just below. Now we're going to need a texture placeholder to plug in for this. So let's travel up over here to where our base texture is, and we can drop down another texture object parameter and another named reroute node, and we can call it custom normal. Now we can head back over to our second normal from height map node and plug in our custom normal reroute node to the height map socket. Now I'm going to reuse our UV's reroute node, but I'm going to plug it into a multiply node with another scalar parameter driving the value. This one I'll call custom normal scale. This way we're in the ballpark with the UV scale to begin with, and we can dial in the custom normal scale with some extra precision. Of course, any changes we make here, and also affected by our primary UV scale settings and any changes we make there. You could always make a completely different set of UVs just for this, but I like to reuse when and where I can. Now we need to create the switch so we can choose which normal texture we want to use. So let's drop down another switch parameter, and let's name it use custom normal. Question mark and connect the result of the first normal from height map node using our base texture, and connect it to the false socket of our switch parameter node. The result of the second node can feed into the true socket. There's our normal setup. We can move on to using our Parallax Occlusion Mapping to drive our UVs now. So let's drop down a texture sample node and our base reroute node. Connect the reroute to the text socket, and now we can connect the parallax UVs to the UVs. Next, I'll want to drop down a set material attributes node and add the following array elements for base color, metallic, roughness, emissive color, normal, and pixel depth offset. Let's take the RGB socket and connect it to the first socket of a multiply node. We're doing this so we can connect a color. We can tint our texture if we want to. Create a vector 3. I'm just pressing the 3 key and left mouse clicking here. I'll pick a soft blue because why not? Now we can connect the out from the multiply node to the base color of our set material attributes node. For metallic and roughness, create 2 more scalar parameters. I'll assign a value of 0 for metallic and a value of 0 for roughness. Just for fun. Let's connect the output of the multiply node to a new multiply node, and then connect another scalar parameter, and let's name it emissive intensity. Connect the output of the new multiply node to the emissive color socket. Now we can finally connect the output of our normal switch parameter to the normal socket. Lastly, let's drag over the out socket for pixel depth offset of our parallax occlusion mapping node to the one on our set material attributes node. Now we're at that point in the chain where we can connect everything up to our materials output node and take a look at what we have. So let's save and head back to the viewport. Let's also make a material instance and assign it to one of our spheres. Now we just need some textures to test it all with. So let's head over to Comfy UI. I'm using the portable web version here. I won't go over the basics of Comfy UI here, but will likely evolve into a series of its own, so keep your eyes open for that as well. Okay, we'll need a few custom nodes. RG3 Comfy, Comfy UI Seamless Tiling, Comfy UI iTools, and Comfy UI Jags Vector Magic. After those are installed, restart Comfy UI to begin. The setup is very simple, and I'll include links to the workflows in the description. I'm using the SDXL Juggernaut XL model, so I can load that into a checkpoint. Create your clip text encodes for both positive and negative prompts. And just above those, let's drop a seamless tile node. Wire the model, clip, and VAE of the checkpoint to the clip encodes and seamless tile node. Now let's get a K sampler and wire that up. We'll need an empty latent image, which I'll set a value of 2048. If your system can handle it, otherwise 1024 is totally fine as well. We can always upscale if needed, but here 2048 is fine for this example. Now instead of a regular VAE, decode node coming next, we're going to use Jags circular VAE, decode node, and that will feed into a preview image node. I'm going to get a load upscale model node and an upscale image using model node. Connect those together, and from our drop-down list on the model loader, if you have the 4x ultra sharp model, give it a try. If not, don't worry, this will still work great with one of the standard upscale models you'll have installed already. Next, I'll drop an image resize node and set it 4096 because that's the size I want my final texture to be. Now I can connect this to a fresh save image node. I'm going to use the dated folder feature to help organize things and keep all our generations going to the same place. And you're welcome to adjust the material to use these textures in different ways as well. Get in there, be creative and experimental, and if anything comes of it that you want to share, I would love to see what you guys have done with it all. Okay, so to get a quick preview of what the tiling will look like, I'm going to get an iTools grid filter. I'll set the width and height to 2048 and leave rows and columns at 3. Lastly, feed that into a preview image node. I've made a few adjustments to our setup that I would like you guys to do as well for this to work as expected. In your seamless tile node, change copy model to modify in place. I've also adjusted my K-sampler to have 30 steps and a CFG of 7. I'm also now using the DPMPP_2M for my sampler and Keras for my scheduler. Now we're going to generate some textures while adjusting our prompt along the way to get some different ideas. I start with a general prompt, something like top-down orthographic view of a seamless 3D grayscale abstract world of alien networks, extending into the darkness. I'll work with several variations to see what I can get that looks interesting to me. I'll speed this up so we can get back over to Unreal Engine and begin plugging these into our material instances. So that's it. Thank you for joining today. Links to the workflow used and materials we made here and from the beginning of the video can all be found in the description below. And if you liked this video and would like to see more like these, please consider supporting the channel with a like and subscribing below. Thank you so much and have a great day.